Hello, this is the luckiest maths teacher in the world, and by the end of this video you will be able to factorize monic quadratic trinomials. But first we better understand what they actually are. So you know from last semester, if I have something of the form y equals mx plus b, that is a linear function. If I graph it, it's a straight line. That's why we call it linear. And we've gone through solving linear equations and linear simultaneous equations. Of course, it doesn't matter what I call the m and the b. I could call them different letters. So I could call it y equals mx plus c, which you may have seen. That's still linear. And I could change the m into a b. Y equals bx plus c is still a linear function. But if I add something times x squared, this term here makes the whole thing no longer linear. It won't be a straight line if I graph it. It's what we call a quadratic. Quad because a square has four sides, and the defining feature of this function is the squared term. So anything of the form y equals ax squared plus bx plus c means that it is a quadratic. Now monic means that the thing in front of x squared is 1. So we're going to be looking today at factorizing things of the form y equals x squared plus bx plus c, a monic quadratic. Now you've actually done these before. So last lesson we did difference of two squares, for example. So you know now how to factorize y equals, say, x squared minus 4. That's just x minus 2, x plus 2, right? That's actually a quadratic. But what we're going to look at today are quadratic trinomials, meaning they have three terms. So you're going to factorize things like y equals x squared plus 7x plus 12. So we're going to go through things like that. Now we can't, unfortunately, use any of the methods that I taught you last lesson. We can't use difference of two squares because this is clearly not the difference of two squares. There are too many terms for one, and there are no minus signs for another. We can't use grouping in pairs because there are not four different terms. And we can't use highest common factor. Now, I said to you, always check if there's a common factor first. Now, there are three terms here. Y equals x squared is a term, 7x, and 12. Each of them is a term. But these three terms do not have a common factor. There is nothing that goes into all three of them. So we can't use the highest common factor method either. So what we're going to do is we're going to use a bit of ingenuity, and we're going to sort of reverse what we're doing in FOIL. So remember, FOIL is expanding. So for expanding, I might start with something like this, and then I end up getting x squared plus 3x plus 2. If you don't believe me, just do FOIL on that. And remember, that's expanding. So for a lot of the questions you did involving FOIL, when you expand the brackets, you get a quadratic trinomial. So that, of course, means when you factorize a quadratic trinomial, remember that's going in the opposite direction. We want to end up with brackets. Then what we're doing is ending up with two terms in brackets, okay? So because of that, I'm now going to go over here and do this question. So because factorizing is the opposite of expanding, we're going to do sort of the opposite of FOIL. So I expect for y equals x squared plus 7x plus 12, I expect that the answer is going to be x plus something multiplied by x plus something. Remember, that's what factorizing is, writing it as something times something, okay? So I only need to fill in those two boxes. Now, it turns out that the way I fill in these boxes is I fill them in with two numbers, surprise, surprise, and they are two numbers that multiply to give the last number, the constant term, 12, and they add together to give the coefficient of x. So if you don't know what those two numbers are, do it methodically. So we're looking for two numbers that multiply to 12. So let's go through factors of 12 and find which of them add to 7. So 1 and 12 obviously don't add to 7, 2 and 6 don't add to 7, but 3 and 4 do. So the answer is I put 3 and 4. Of course, it doesn't matter in which order I put them in because I'm multiplying. So x squared plus 7x plus 12 factors to x plus 3 multiplied by x plus 4. Okay, it's as simple as that. So let's do another example. So let's say I have y equals x squared plus 5x plus 6. Okay, so again, I know it's going to be x plus something multiplied by x plus something. So I want two numbers again that times to give the n number and that add to give the number in front of x. So I go through factors of 6 and I see 2 and 3 fits. Okay, so let's say I have something like this. So y equals x squared plus 3x, but I'm going to have a minus one now, minus 40. Now we have to do this slightly differently. My answer is still going to be x plus something multiplied by x plus something, but the two numbers need to multiply to negative 40 and add to positive 3. So we still go through the same process. We look at factors of 40 and we want ones that differ by 3. So once you go through them, you'll see 8 and 5 differ by 3. So I put an 8 and a 5 in, okay? The problem is they can't both be positive because 8 times 5 is positive 40 and 8 plus 5 certainly doesn't equal 3. So one of these has to be negative. So how am I going to get 8 and 5 to 3? So obviously, think about it, I've got to have a positive 8, but this plus here has to become a negative. So I get rid of the plus and it becomes a negative because 8 plus negative 5 equals 3 and 8 times negative 5 equals negative 40. Okay, I'm going to do a few more examples on a different slide, so please copy this down if you need. Okay, so let's say I have something y equals x squared minus 10x plus 24. Okay, so again, I need two numbers that multiply to 24 but add to give negative 10. Okay, so because the last number here is positive, I know that and I know that my answer is going to look something like this. I know that both of the numbers that go in here must be either positive, so they're either both positive or both negative, because you can't have a negative and a positive multiplied to a positive. So because this one here is negative 10, they obviously must both be negative. So I'm just going to rub out the positive signs and replace them with negatives. Okay? So obviously both going to be negative, so factors of 24 that add to 10, of course, are 4 and 6. So it'll be negative 6 and negative 4. So sometimes the numbers will both be negative, sometimes both positive, sometimes one will be positive and one will be negative. I just want to give you one more example. So let's say I have something like y equals 2x squared plus 8x plus 8. Now this isn't a monic quadratic, but as I told you, I want you to always try and see if you can use highest common factor first. Unlike all the other examples I've given you, these three terms in this question, 1, 2, 3 terms, they have a common factor. It is 2. So the first thing I do is divide by this common factor. So what do I times by 2 to get 2x squared? I'm just left with x squared plus, so 2 times 4x equals 8x, and 2 times 4 equals 8. Okay, now I can do the tricks that I've been showing you on this set of terms here. So I need to find now two numbers that multiply to 4 and add to 4. Now those two numbers turn out to both be the same, 2. So it's the same thing. It's x plus 2 times by x plus 2. I do that with the exact same process. So what I can do is write 2 times x outside of x plus 2 squared because the 2 is repeated, okay? So I'll give you a quick summary. So here is a summary of what we've gone through. So we're trying to factorize things of the form x squared plus bx plus c. So we know that's going to be x plus something times by x plus something. So the two numbers that go into the boxes are two numbers that multiply to give this number and add to give this number. And you try and use the highest common factor first if you can, if it's not monic. So these three down here, I'm not sure whether they'll help you or not, but sometimes it can be hard to think whether this number and this number, whether they're negative or positive or whatever. So if both b and c are greater than 0, so let's say I have y equals x squared plus 8x plus 15, I know that both of the numbers are going to be positive because b and c are positive. So both the numbers that go in this box and this box are positive. If b is less than 0 but c is greater than 0, so let's say I have, y equals x squared minus 9x plus 18. So I know straight away that both of the numbers that go into those boxes have to be negative. In this case, they're minus 6 and minus 3. But if c is less than 0, c is negative, it doesn't matter what b is, we will always have a positive and a negative number. So in this case, the numbers would be that go in the boxes, that is, would be minus 1 and positive 6. Okay, so please ask if you have any questions. Other than that, have a great day. This has been the luckiest maths teacher in the world.